Okay, this is problem 11 from chapter 7. We have this roller coaster, this cart's coming down. It says when it gets through this loop at the top, it's going 8 meters per second, and when it gets down to the bottom, it's going 25 meters per second. The cart is 120 kilograms, and this distance between the bottom and the top is 12 meters. It's wondering, what is the work done by friction from the bottom to the top? And so we need to figure out the total kinetic energy, the total energy between the bottom and the top. So we're going to do several different equations here. So first, we want to figure out the kinetic energy of the bottom. We don't need to figure out the potential energy of the bottom because it should all just be kinetic when we're at that point. So we're going to be using Ke equals mv squared, 1/2 mv squared. And I'll set it up for us. So we're going to be using this equation several times. So Ke equals 1/2 mv squared, and we just plug in, and this is our kinetic energy for the bottom. So I'm going to do Ke sub b for the bottom, and that comes out to 37,500 joules. That's our total energy for the bottom because it's all kinetic. Now for the top, we need to figure out the kinetic energy and the potential energy because it has potential energy at the top of the roller coaster. So we're going to use the same equation first to figure out the kinetic energy. And we'll do Ke sub t for the top. That's 1/2 120 times 8 instead, squared, which comes out to 3,840 joules. Show you what we did there. The kinetic energy for the top comes out to this. Then we need to figure out the potential energy of the top, which is mgh, which we're given by the equation, by the problem. So potential energy sub T equals our mass times our gravity times the height, which we were given as 12. Okay, I'm going to need to make more space here, but down at the bottom here, let me get it closer. We have our total kinetic energy for the top was 3,840. Our total potential energy at the top was, 29,400. So we added those together to get the total energy of the top is 33,240. So now we have all the pieces we need to figure out what our work done by friction is. Let me just make some space here for these. And to find the work done by friction is pretty simple. The work done by friction is the negative of the bottom energy plus the total energy of the top. So we come to the conclusion that our work done by friction is the negative of what we figured out before was our bottom energy, kinetic energy, plus the total energy of the top, which comes out to negative 4,260. And I say negative, the reason why we made that negative is because work done by friction is negative. So we have negative 4,260 joules for our work done by friction.